Welcome to the Property Elite podcast. I'll be your host, Jen Lehman, chartered surveyor and co-founder of Property Elite. Stay tuned each week for more on industry hot topics, market updates and new RICS guidance. In this week's podcast, we're going to be looking at part 2 of a 2-part podcast and blog series, focusing specifically on types of damp and how to diagnose them accurately. So first question, is rising damp a myth or a reality? In 2008, Jeff Howell, in his publication The Rising Damp Myth, declared that generations of surveyors were wrong when it came to rising damp in buildings. It was claimed that chartered surveyors as a profession simply didn't understand damp meter results, and this was leading to a failure to understand building construction technology and historic building regulations dating back to 1877. Whilst the phenomenon was a matter of long-held collective wisdom, there was little in the way of supporting research, leading to the contention that rising damp was simply a myth. RICS in the Property Journal in November 2020 published an article drawing attention to a published thesis by Leslie Sellers entitled Rising Damp, Evolution and Treatment, a quasi-experimental case study, for which he was awarded a doctorate in the built environment. The article concluded that rising damp is a real phenomenon that warrants treatment in the contemporary method of damp proofing, installed as it would be on a real construction site, does provide effective control. So, surveyors can now be assured that there is research confirming that rising damp is a real phenomenon. Rising damp is the movement of moisture upwards through permeable building materials by capillary action. It's more common in old pre-1919 buildings than new ones, but rarer than often supposed. It's a significant factor in only a very small percentage of reported rising damp cases, and an analysis found that only 5% of the cases reported as rising damp actually were. The rest were due to block cavities, bridge wall ties, bridge damp-proof courses, or a lack of a DPC DPM lap. So how high can rising damp reach? Traditionally, it's been understood that rising damp can go no higher than 1 metre, but this height is a theoretical calculation and cannot be taken as an accurate guide. Research has identified several examples where rising damp heights of 5 to 6 metres have been documented, such as in the Basilica of San Marco in Venice. The 1 metre theoretical height, therefore, doesn't consider real-life factors that occur, such as bricks of variable porosity, mortars of variable mix, occasional built-in timbers, plasters, renders, paints and other finishes, and the moisture travelling through the bricks being of a variable makeup. Several other factors that affect height are height of the water table, which may be rising in areas where heavy industry is no longer present, surface and subsoil drainage, rate of evaporation, lack of a DPC, DPC bridging, wall finishes, particularly if dense renders are present, wall thickness, the amount of foundation wall surface underground, the presence of salts, and the presence of moisture entering the wall above ground from another source. So moving on, what else contributes to the misdiagnosis of rising damp? Poor surveying techniques or understanding of the limitations of the equipment used often contribute to this. In the book Diagnosing Damp, the authors, Mike Parrott and Ralph Birkinshaw, identified there's 4 stages in the investigation of a damp problem. 1. Visual inspection of the property. 2. Inspection with the use of a moisture meter. 3. A more detailed inspection. And 4. Involving opening up and sampling, which may result in damage to finishes. Most initial surveys on a house or commercial property will only be able to carry out the first 2 of these stages. Yet, often a diagnosis of rising damp is made based on this initial limited survey. The well-known tide marks shown in BRE can also be caused by the cavity being bridged by mortar in the cavity. Furthermore, the readings from damp meters taken in plaster alone can be misleading. This is because the pins on a moisture meter don't go all the way through the plaster, so the reading only indicates how wet the plaster may be, not how wet the wall is. The readings can often be suspect because of the possible influence of hygroscopic salts, condensation, and ambient humidity. However, quite often surveyors are giving a diagnosis of rising damp without considering that the cavity being bridged by mortar in a cavity wall, mortar on cavity wall ties, or the plaster on the wall being taken down below the DPC, or there being no DPC DPM lap, allowing water to rise in the gap between the concrete slab and the wall. The most common source of moisture in the base of the walls of buildings is from defective ground and surface drainage. This is present to some degree in almost every building in the country due to a combination of factors such as rising ground levels, the failure of ground drainage systems, and the increased use of concrete or finishes around buildings without consideration of drainage slopes. The accumulation of moisture reservoirs in the foundations may also arise as a result of chronic plumbing leaks or floods from catastrophic plumbing or drainage defects. Condensation can also create damp problems at the foot of walls, but this is not often considered or understood. So let's look next at rising damp in concrete floors. This is much less common than in walls and is often confused with excess residual construction moisture, a common problem in new buildings. Whilst modern concrete floors have a DPM beneath the concrete to prevent water coming through, older floors do not. The form of the DPM in older buildings, especially residential, may not be recognised by modern surveyors. Floors laid between 1945 and 1966 may or may not have a DPM, whilst those laid before 1940 will almost certainly not have one. In many houses built in the 1950s, the only barrier to rising damp was the bitumen embedding material under the wood blocks or thermoplastic tiles. It's common to find during a refurbishment that the wood blocks or vinyl tiles have been removed and the bitumen damaged by contractors with no appropriate knowledge, thereby reducing the effectiveness of the DPM, leading to rising damp. A moisture barrier installed in the 60s or 70s may not be up to current standards and may not perform as well as contemporary solutions. In some cases, a simple polythene sheet may be all that separates the slab from ground moisture. Over time, a substandard membrane can break down or become perforated, reducing or eliminating its ability to control moisture intrusion. Quite often, concrete slabs laid as a replacement floor in a Victorian kitchen will not have a DPM at all. The use of a damp meter for measuring if damp is rising through a concrete slab is very limited. A humid or wet environment will likely cause false or inaccurate readings of a concrete slab's moisture when taken at surface level. As concrete's electrical properties are varied and do not change just because of the presence of moisture, it makes moisture meters useful for guidance measurements only. So this is the end of part 2. Stay tuned for part 3 of this podcast and blog series where we'll be looking at testing to diagnose dampness and other causes of dampness. Thanks for listening to the Property Elite podcast this week. Head to our website to check out our full blog, free and paid support resources and services, free consultation for every single RICS APC and RICS candidate, and also ask us any questions you have via the website chat blog. See you next week.